So guys, in this lecture we'll be talking about understanding the certified ethical hacking. So ethical hackers are employed either through contracts or direct employment to test the security of an organization. They use the same skills and tactics as a hacker but with permission from the system owner to carry out the attack against the system. In addition, ethical hackers do not reveal the weaknesses of a evaluated system to anyone other than the system owner. Finally, ethical hackers work under contract for a company or a client, and their contract specify what is off limit and what they are expected to do. The role depends on the specific needs of a given organization. In fact, some organizations keep teams on staff specifically to engage in ethical hacking activities. So, network topologies. Network topologies represent the physical side of the network and they form part of the foundation of our overall system. Before we explore too far, the first thing you need to understand that you must consider two opposing yet related concepts in this lecture. So, this is the physical layout of the network and also logical layout of the network. The physical layout, as you can see in this here, of a network related directly to the wiring and cabling that connect devices. Some of the common layouts we will cover is like bus, ring, star, all of those are topologies. The logical layout of the network equates to the methodology of access of the network. The stuff you cannot really see or touch or the flow of information and other data. We will get to the logical side, but first let's break out each of these physical design. So the bus topology, as you can see in this picture, lays out all the connection node into a single run and the acts of the common backbone connection for all connected devices. As with the public transport, of the same time signals gets on travel on their destination and get off. The bus is the common link to all devices and cables. The downside to it is simplicity and its vulnerability. All connectivity is lost if the bus backbone is damaged. So the best way to evasion this vulnerability is to think of these strings of Christmas lights that go completely out when one light burn out or is removed. Although not seen in purest form of today's network, the concept still applies to the particular segment. So let's talk about open system interconnection model. No network discussion or network device explanation would be complete without a brief overview of this OSI model, which is Open System Interconnection. Although this model OS seems overly complex, it does have a value in later discussion of our attack defense and infrastructure. As you will see, the OSI model is a general framework that enables network protocol, software and system to design around a general set of guidelines. Common guidelines allow higher probability of system capability and logical traffic flow. In other words, if we all play the same rules, everyone will get along as few years as possible. The OSI model shown in this picture has 7 layers. As you can see, each layer has function. Keep in mind that we are working on our way to how the data flows. Each layer is connected to the next and this concept will prove valuable in a reference for more advanced data analysis. So, the first layer is, as you can see, at the end and the lower, which is physical. So, the physical layer consists of the physical media and dumb devices that makes up the infrastructure of our network. Then the second one is data link layer. The data link layer works to ensure that the data is transferred is free of errors. Layer 3 is network layer. The network layer determines the path of the data packets based on the different factor as defined by the protocol that it used. At this layer, we see that IP addressing for routing of the data packets. So layer 4, transport layer. The transport layer ensures the transport or sending the data is successful. Layer 5, which is session layer. The session layer identifies established system session between different network entities. When you access a system remotely, for example, if you are creating a session between your computer and the remote system, the session layer monitor and control such connection. Layer 6, presentation layer. The presentation layer provides a translation of the data that is understandable by the next receiving layer. And the layer 7 is application layer. So the application layer function as a user platform in which the user and the software processes within the system that can operate and access network resources. So that's all about this OSI model. So let's now talk about TCP or IP suite. Complementary to the OSI model is the TCP/IP protocol suite. TCP/IP is not necessarily a direct offshoot, but it's progressive step from the standard OSI version of the traffic flow. Each layer of the TCP or IP suite maps is to one of the several layers to the OSI model. So let's go and deep dive to this. So TCP is known as connection oriented protocol. So as you can see in this picture, this is the TCP three-way handshake, as we already heard from somewhere, three-way handshake. So this is how this three-way handshake works. So it establishes a connection and verifies the packet that sends to the connection and make it their destination. The process, as you can see in this, it starts with SYN packet. As you can see, this process starts with SYN packet. This SYN packet starts the handshake process by telling the receiving system that another system wants its attention, which is via TCP, of course. The receiving system then replies to the originating system with a CNAC response. A CNAC response is an acknowledgement response to the original SYN packet. Once the original sender receives the CNAC response, it in turn responds with ACK packets to verify that it has received the CNAC and is ready to communicate via TCP. So that's how this three-way handshake usually works. So now let's talk about TCP or IP ports. Ports allow computers to send data out of the door while simultaneously identifying the data by category. What this means is each of the common ports that you use is associated with a particular protocol or particular application. So let's go and deep dive of these ports. So for example, sending data from port 21 signifies the receiving system that the traffic received is an FTP request because of the port it came from. So in addition, the response from the initially required system will end up at the right location because of the port which the traffic came has already been identified. So first now let's take a look how these ports are categorized and how the well-known ports are mean to you. So well-known ports are most commonly in daily operation and range from 1 to 1023. Much of this initial portion of this range should familiar to you, which is this table. As you can see, this is all of the basic use ports in our network. So register ports from 1024 to 49151. Registered port are those that are being identified as usable by other application running outside the user's purview. So as an example, it would take 1512, which supports Windows Internet Name Service. So take a look at these ports. These are the registered ports, as you can see: 22 SSH, 23 Telnet, SMTP, Windows, DNS, 8080 HTTP. So all of those ports are in here, as you can see, based on this. So there is another one also, like 1080 for SOX 5, 1241 for Nessus server, and this for SQL server. So all of those ports are in here. So these are the ports that are available for like TCP, UDP that made the applications, and these are the available for support application that has not been officially registered in these specified ports.